Hello geometry students, today we are going to learn about inscribed angles and polygons. That's section 10.4 from Big Idea Geometry Student Journal. It's on page number 295 to 296. So in this section we are going to learn four theorems. Theorem 10.10, measure of an inscribed angle theorem. Next theorem is 10.11, inscribed angles of a circle theorem. Then 10.12, inscribed right triangle theorem, and 10.13, inscribed quadrilateral theorem. So let's start moving to the vocab part first. Let's learn few important definitions. So here what we are supposed to know in order to understand the theorem, we are supposed to know three important definitions. Central angle is basically, because it says the name has central, it means the angle is supposed to be made at center. So it's should be created or subtended at center. Here you see that the angle is at center, so that's why it is called central angle. Now next one is inscribed angle. Inscribed angle, this is always on circle, always on circle, so it's going to be always on circle. All right, it's going to be here. Whenever an angle is formed at the circle, that's going to be inscribed, and whenever an angle is formed at center, this is on center. All right, so it's always on center, then it's a central angle. When it's always on the circle, it's going to be inscribed circle, inscribed angle, and intercepted arc is the arc which is creating these two angles. So for central angle, this is the inscribed arc, intercepted arc here, because this arc is creating this angle, and the same way this arc is again creating this angle here. You can see the ends of arc when you connect at center, it makes a central angle, and the same thing when the end of arc, when you connect it to the circumference, you see it creates inscribed. So always keep in mind difference between central and inscribed. Let's move to another definition, that's called inscribed polygon. Inscribed polygon is a polygon. Just imagine a circle and you see a circle inside, in a polygon inside, but it's all vertices should lie on the circle. So if it is touching here, this vertices is touching here, this vertices is touching here, this is touching here, here, and here. So if it is touching at the on the circle, all the vertices, then it's going to be called inscribed polygon, and the circle which is around it, that is called circumscribed circle. So this circle around it, this is circumscribed circle. All right, so if I look at the other example here, so in that case, this is our circumscribed circle, and this is our inscribed polygon. Because here this vertices is touching here, and the vertices is touching here, and this vertices is touching here. But if in case if I have a circumscribed circle and I draw my polygon like this, does it touch this vertices? Does it touch here on the circle? No. So this is not an inscribed polygon. Keep in mind all the vertices should touch the circle. Let's move to the next. The first theorem of this section is measure of an inscribed angle theorem. Inscribed angle. Keep in mind what I told you. Inscribed is always on the circle. It is always on the circle. It's not going to be at the center or anywhere else. So it is always 1/2 of the measure of its intercepted arc. So if this is the arc here, AB is the arc, so this is the inscribed angle for that. Inscribed means it's not forming on center, it's forming on circle. So this arc is always, this one is always double of this, or you can say this is half of this. So measurement of angle ADB, that's going to be half of measurement of arc AB. And by the way, how do you find this measurement of arc AB? That's actually the measurement of central angle. If you know how much is this, if this is 2x, so this is going to be 2x degrees, and the inscribed angle is going to be x degrees. All right. So let's take an example. Here we have a circle, and then if suppose I say here that I know this is the intercepted arc, this is the inscribed angle. Keep in mind, this is, so for inscribed angle I'm using IA. This is inscribed angle, and I have to find out, and suppose I say this is 40 degrees, and I have to find how much is intercepted arc. Intercepted arc is going, this is 40, so this is going to be twice of 40, means that's going to be 80. That's always double. And actually, how do you know? So this is basically, you have to remember, whatever the arc measurement, the intercepted arc is always, angle is always half of the measurement of this arc. And how we get that? That's actually, we get it from here. It's the measurement of the central angle. So it is supposed to be also 80. So this is just how I'm explaining why. All right, let's move to the next theorem. Next theorem is inscribed right triangle theorem here. So what do we have? If we have a inscribed right triangle, means it is supposed to be inside a triangle. If we have inscribed a right triangle inside a circle, then hypotenuse is a diameter. Or conversely, if one side of inscribed triangle is the diameter of the circle, then triangle is a right triangle. So what does it mean? It means if you see a circle here, there is a circle D. If you see the circle D, in that circle, if you see a triangle where the angle is a right triangle, then you can see it means this side, the hypotenuse, this is your hypotenuse. In this case, it is AC. This is your hypotenuse. All right, that's going to be your diameter. All right, could not write it here, so that's going to be a diameter. All right, or if you see this is a diameter, so any angle formed will be a 90-degree angle. So the triangle is going to be right triangle. So measurement of angle ABC, if that is 90, if and only if AC is the diameter of a circle. So what does it mean? If I see this is 90 degree, if I see this is 90, then I can say this is a diameter. So basically what I mean, if I see this is 90, then my prediction, this is going to be diameter. All right. If I see vice versa, other way, if I say that this is diameter, then any triangle, if I form any triangle inside, suppose this is my triangle here, and this is touching here. Let me just make this line better. So here, if I have another inscribed polygon and it touches here, and I know this is a diameter, then it's obviously going to be right triangle. This angle is going to be 90 degrees. So that's you should keep in mind, a triangle in a semicircle is going to be a right triangle. So this angle is always 90 degree. That's inscribed right triangle theorem. Let's move to the next theorem. Next theorem is inscribed quadrilateral theorem. So if you see a quadrilateral that is inscribed in a circle, if and only if it is opposite angles are supplementary. What it is, if you see a circle here and the polygon is inscribed, so inscribed is which one? This one is inscribed here, and that's inscribed. And how it is inscribed, keep in mind, it is all the vertices should touch the circle. If it is not touching, it's not inscribed. So here it's touching. Then what do they mean? They say that opposite angles are supplementary. So which are going to be the opposite one? E is opposite to G. They're going to be supplementary. And what was the definition of supplementary? That sum was going to be 180 degree. You remember that? So if I say measurement of angle E and measurement of angle G, that's going to be 180 degree. And same way we have another pair of supplementary angle, another pair of opposite angle. We have this angle F is opposite to angle D. So I can say measurement of angle D and F, that's also 180 degree. No matter how the quadrilateral looks like, but whenever you add the opposite angles of a quadrilateral, keep in mind it's about quadrilateral means four sides, polygon having four sides. It's not applicable to any other. Here it should be a quadrilateral, and then it has to be inscribed. It should touch all the four vertices to the circle. So like if I have drawn another picture here, if I say if I just like hypothetically, if I assume some values, suppose I give it X and this is Y, and then if I say this is Z and I say W. So if I have to write down my equation here, so this is, let me make it degrees. If I have to write my, according to this theorem, what it is going to be, I can write X plus Y is 180 and W plus Z is going to be 180. It's something like that. So whatever the measurement here, it's going to be like this. So in case if I say that this is suppose if I say this is going to be 70 degree, how much this going to be? Because they're opposite, so there's going to be 110. If it is like that, the both together has to be 180. Same way you can always check for here. So if you get an expression XYZ, you can use that and create your equation, solve it for XYZ and plug it in that. So we are done with the notes part of this section. I hope you get it. So in the next video, I'll be doing some problem based on these theorems. Till then, stay safe. Thank you so much for watching.